Hi there everyone. Today we're going to look at how to solve an equation. Now to start off with, I'd like to ask this question. So it might seem pretty difficult or pretty easy depending on how you're looking at this at the moment, but what is 5 add 1 equal to? So you might need to take a moment, you might need to pause the video and think, what's this guy talking about? Obviously the answer is 6, but I'm asking for some more answers. Now, if you've had a think about it, maybe you've written something like this. Because 5 add 1 equals 4 add 2. We know that, don't we? There's actually an infinite amount of answers that we can do here. So like, for example, 7 take away 1. You can say 6 to the power of 1, something like that. Use some indices in there. And the reason I ask this question is because I want you to realize the power of this symbol here, what this symbol actually means. And essentially, it is the same as. When you understand that, it makes things very, very simple. Let's for example, let's just say, this is a bit of a weird thing to write down, but here we go, 6 equals 5 plus 1. What happens if I add 1 to this side? Well, if I add 1 to here, I get 7. So you'll see that this is no longer the same because I've upset this equal sign. So to keep it equal, what do I have to do? Well, I have to add 1 to this side as well. So I could just put another 1 here. So now both sides are equal to each other. And it's important to remember that what we do to one side, we must do to the other. And with simple numbers, it's really easy to see. We're going to take those simple numbers away, and we're going to give you something that looks like this. And it's kind of nice. It's like a little mystery. We've got this symbol here, x. This is what we use for representing most unknowns in the math world. So the question is, what is this value equal to? Well, there's a few ways you can do this. There's learning a nice methodological way, or you can play the I'm thinking of a number game. And we did this in a previous video. So we said, I'm thinking of a number, I times it by 3, I add 2, and I get 17. This is a really mathematical way of playing that game. So if you think about what you would normally do in that game, I'm pretty sure you'd agree you'd remove this 2 first. So we're going to take away a 2. And remember what I said about that equal sign is for it to be equal for this side, this left-hand side, to be the same as the right-hand side, we have to do the same to both sides. And a nice little trick here is to keep that equal sign in a line. Some people like to do like a dotted line right at the very start. But you know, personally, I don't bother. But if you play the I'm thinking of a number game, you would agree, I'm sure, you're going to remove that 2 first. What would it look like? It would look like this, wouldn't it? So this 2 take away 2, that's now going to go. So we're only going to be left with 3 x's. So we've got 3 x's here. And if we follow this one down, we get 15. So it's exactly the same as this. What I did to one side, I had to do the other to keep it equal. So if I take away 2 from this side, I have to take away 2 from that side to keep it equal. But that wasn't the question. The question means find out what x is. So now we have this problem, 3x. So 3x is a 15. I think you might just be able to see it's 5. But if you can't see it, this is 3 of something. To get 1 of something, we need to get rid of this 3. And what's actually happening? It's being times. So if we divide by 3 to this side, for it to still be equal, we need to divide by 3 to both sides. And 15 divided by 3 is 5. 3 divided by 3 is 1. We don't write a 1 in here because we're good mathematicians. So let's have a look at 3 of them. You know, it's up to you if you're watching this from home. You can pause the video, have a go. If you're watching it in school, in a cover lesson, whatever, then you can just carry on watching. So if you play the I'm thinking of a number game, it's I'm thinking of a number, I times it by 5, I then take away 1, and I get 19. So we're going to get rid of this first. So we're going to plus 1, and we're going to keep our equals in a nice straight line. What will happen here? Well, they're going to disappear. So we're just left with 5x on the left-hand side, and on the right-hand side, we've now got 20. We've got 5 of something, we only want 1 of something, so we're going to have to divide it by 5. Remember, they're being times. To get rid of something, you have to do the opposite. And what I do to one side, I have to do on the other side. Sorry, I was meant to write that in blue. Just make it look a bit nicer, easier to follow. 20 divided by 5 is 4. Yeah, so when you're doing these yourself, I'd advise you to use a different color here, just so it pops out and you can see the nice visual journey. People make mistakes. They write 19 plus 1. For some reason, they write 19. So just make sure you do follow your working. So have a think, what's the first thing we're going to get rid of here? And you should have come up with a 4. So how do we get rid of a plus 4? We minus a 4. Right, so 4 take away 4. Get the equals in a nice line first. So 4 take away 4 is 0. So we're just left with 7x. 46 take away 4 is 42. Get the equals in a line. Think about what we're going to do here. Divide by 7. Divide by 7. And x is 6. Okay. Even if you can see it straight away, I need you to do the full working. The reason for that is what comes next will be harder. The year after that, even harder. And if you don't have a nice nice structured way, I can't say that word, nice structured way, then you aren't preparing for the future. So please do that. And you won't see this next one as easy. This might confuse you if you're not following the structure. So, but to start off with, it is exactly the same. We're going to add 5 to both sides. We're going to get our equals in a nice straight line. We're going to be left with just 6x on the left-hand side, and 11 plus 5 is 16. But normally, when in a friendly situation like 7 6s are 42, 5 4s are 20, we are now in a non-friendly situation. These numbers are non-friendly. But we're still going to go ahead and put our equals in a straight line. We're going to get our x ready. We're still going to divide by 6 to both sides because we want to preserve the equal. So what is 16 divided by 6? It's not very clear. They are division. Sorry about that. Is 16 divided by 6 the most mathematically way you can write it is just 16 divided by 6 using a fraction. You don't have to go top heavy. You don't even need to cancel it down, but if you want it to be a bit better, you could. 8 over 3. Okay, that's a fantastic answer. But that's it. You don't try and write decimals. Keep it as a fraction. You simply write 16 divided by 3 in a more mathematical way and just leave it there. So when it's non-friendly, many people find them easier. I will say what goes wrong is they often put these numbers round the wrong way. But look, what's on the top here? 16 is on the top. It stays on the top. 6 here is on the bottom. It's below the 16. It stays below. So just don't get it wrong. Now, these ones are a bit trickier. These are the last ones we're going to do. And you'll notice here the x term is negative. You see here, minus 2x and minus 3x. So the x term is negative. That's a shorthand way of writing negative. And that is troubling. There are many ways you can do it, but there's only one way I will recommend to you, and it's to make it positive. So at the moment, you should have grasped that if I get rid of something here, obviously I'll get rid of it here. If I add something here, it must pop up here because of the equal sign. So if we add 2x, just bear with me for a minute. If we add 2x, I want you to see something. The minus 2x will disappear here because we've got minus 2x, add 2x. That's going to be 0. Equals in a line, and on the left-hand side, we have 7. And on the right-hand side, remember these are not like terms, and I'm going to pop the 2x first because I just like it looking that way. We've now got 2x plus 3, and this is where we were on our previous questions. When it's minus, just add it to both sides, make it positive. And then we start again. So I'm thinking of a number, times by 2, I add 3, I get 7. So I'm going to take away 3 first, make sure I do it to both of them. I'm left with 2x on the right-hand side. These are going to cancel out. And 7 take away 3 is 4. Nice friendly situation. So x is 2. I'm just going to go ahead and pop in my divide by 2's. It's important not to just start skipping, just to keep this process nice and fluid. I'm going to just change that so it's a non-friendly for a second. So I'm just put 17 there. Okay, so it's a negative x. Let's make it positive. We do the same to both sides. Equals in a line. On the right-hand side, we've got 3x plus 17. All the x terms are going to disappear here, and we get 32. I tried to make it non-friendly. The one random number I made still makes it work, annoyingly, but you get the idea. So take away 17, just the same as all the other previous 5 we've done in this video. So I'm going to speed up a bit here. And we get 3x on the right, the 17s are going to cancel. And what is that? That's 25. Oh no, it's okay. It still works. Is that 25? No, it's not. It's 15, isn't it? 20. No. Oh, I'm having a moment here. I'm having a really big moment. See, I hate subtracting. Anyone that likes it, it's crazy. It's 15. Of course it's 15, you silly man. So 15. And we're going to divide by 3. Divide by 3. And we get x is 5. It doesn't matter which way round you write these. You can write x equals 5 or 5 equals x. It's the same thing, right? So it's just a matter of practice now. And yeah, if x is negative, make it positive. If it's not negative, just crack on. If it's a non-friendly, just remember to write it in this form. Hope it all makes sense, and best of luck.